Um, so welcome to Logic online version. Wasn't what I was expecting to be doing for the rest of the semester, but I hope you guys are all doing okay. We're spread out all over the world, but thankfully this is happening in the time of internet, so we can continue with the class. I just thought I'd wear a hat for the occasion. I'm not practiced at this. I've never done an online course, so we'll just have to see how this goes. It's going to be a little bit of a learning curve at first, but anyhow, let me just start. So we left off last time by looking at how to symbolize things in first order logic with quantifier phrases. And specifically, we were looking at existential quantifier phrases. So this is now material from the textbook in section 5.3 to 5.4. And what we saw there is that, right, when you're doing these more complicated kinds of symbolizations, it's useful to distinguish the restrictor predicate from the main predicate. The restrictor predicate is telling you what group of things that you're talking about. So if you say some logician is wise, the group of things that we're talking about are logicians, and then the main predicate is basically the verb phrase, which tells you what is true of some, or in other cases, all, or whatever the members of the collection in question. So here we have some logician is wise, but then you can have some short logician is wise. So here, or some short logician fell down rather. So here, now the restrictor predicate is short logician, and the verb phrase is fell down. Or to make it even more complicated, some short logician from New York is wise but not happy, right? So it's important to distinguish those, because what happens when you're doing symbolizations with some, with the existential quantifier, that those two predicates, the restrictor and the main predicate, are always joined through a conjunction sign like this, like you see. So you just write whatever the restrictor predicate is, in this case, short logician from New York, right, using S for short, L for logician, and N for being from New York. That's our restrictor predicate, and it's then joined to the main predicate using a conjunction sign. Remember that technically also the existential quantifier always ranges over a domain. So what there exists an X WX says is that every object X in the domain is such that it is wise, let's say. And so whenever we use a quantifier, we should always specify what our domain is, and which domain you pick can actually affect the symbolization. So for example, someone is wise can just be symbolized as there exists an X such that X is wise, assuming that we have the domain of people. But suppose we're dealing with a wider domain that contains things in general, so not just people, but also, planets and rocks and trees and things like that. Then to get the point across of someone is wise, where we're specifically talking about some person, right? Now, the fact that we're talking about people is no longer built into the domain. Now the domain consists of things in general. So the fact that we're talking about people would now have to be made explicit with an extra predicate, P, for being a person. So in the domain of things, the way I would have to symbolize it is there exists an X such that X is a person and X is wise. That's what's required to get the impact of someone is wise. Whereas again, if we just had a domain of people, I can just say there exists an X in the domain of people such that X is wise, and this says there exists an X in the domain of things in general such that X is wise. So what you can see here basically is that what is done with a domain restriction here is being done with an explicit restrictor predicate in this case. Now consider some logician is wise, right? We saw the restrictor predicate there as being a logician, and the main predicate is being wise. So some logician is wise would be symbolized like this, assuming again that we're using a domain of things. You would say there exists an X in the domain of things such that X is a logician and X is wise. But now, if we were allowed to use a domain of just logicians, let's say, now this sentence could just be symbolized this way, because now what this would be saying is there exists an X in the domain of logicians such that X is wise, right? So what is being done with the domain here is being done with an explicit restrictor predicate here, just as in the case up here, where what's done by restricting the domain to people up here, once we expand the domain, it's going to be have to be indicated by an explicit restrictor predicate. All right, so in principle, we could choose any domain that we like, but we're not actually going to be using domains like logician, like just logician. So we're never going to use this as a symbolization of some logician is wise, because we don't want to build the fact that we're talking about logicians just into our domain. We want to make it explicit in the symbolization by actually using a predicate. So we're actually going to only be using two kinds of domains. And here's the rule for selecting domains. If an argument or a sentence that you're symbolizing only contains quantifiers that are implicitly restricted to people. So these are quantifiers like someone or everyone or no one that are used to talk about people. So if you only have those kinds of quantifiers and you don't have any predicates or names that concern anything other than people, then you can just use a restricted domain of people. But in all other cases, we're going to be using the widest domain, the domain of things in general. And then again, if you're using that very wide domain of things in general, but you still need to symbolize a quantifier like someone that's restricted to people, then in that wide domain, you need to use an explicit predicate for being a person to symbolize these kinds of quantifiers. All right. Right, so again, here with someone is wise, we have a choice. We could use a domain of people and symbolize it like this, or a domain of things, but then we would have to symbolize it like this and make the restriction to people explicit. With some logician is wise, since it's not a someone or everyone or no one sentence, we're just going to use a domain of things and symbolize all the predicates explicitly. We're not going to be doing things like what you see down here, where you would have a domain that just contains logicians. All right. So let's do some examples. So we have, and this is going to be, see how this works. If I can get this to work. So we have, let's say, some dogs are friendly. This would, let's do these two. All right. So we're here obviously using a domain of things, right? Not just people, because we're not dealing with someone or everyone type sentences. We're dealing with some dogs, so we need things in general. And I'm going to use D for dogs and F for friendly. So here we have as our restrictor predicate, right? We have some dogs, that's our restrictor predicate. The main predicate is are friendly, and we're going to be conjoining those with an and sign. So the way to symbolize this is there exists an X such that X is a dog and X is friendly. So that's in the domain of things. There exists at least one X such that X is a dog and X is friendly. Right, again, it didn't matter that I used the variable X here. I could have used Y and said there exists some object Y in the domain of things such that Y is a dog and Y is friendly. As long as you pick, it's just that the variables that you use with the predicates here have to match the variable on the quantifier. All right. Now, what about this one? Some dogs are neither friendly nor cute. So this is a slightly more complicated example. So again, the restrictor predicate is just dogs, but now the main predicate is are neither friendly nor cute, right? And again, we're going to put those together with an and. So we have for number 2, so this was number 1. For number 2 now, again, using D for dogs, F for friendly, and let's use C for cute, we would have now some dogs are neither friendly nor cute becomes there exists an X such that what? Well, X is a dog, and now we have to do the main predicate. What's that going to be? Well, neither friendly nor cute. So if you remember how to symbolize neither nor types things, it's a negation of a disjunction. So not X is friendly or X is cute. So there does not exist an X. So what it's saying as a whole is that there exists some object X in our domain of things such that X is a dog, and it's not true that X is either friendly or cute. X is neither friendly. Of course, an equivalent way of saying that would be, by De Morgan's law, there exists an X such that X is a dog and X is not friendly, sorry, and also not cute. So by De Morgan's law, we could transform this into this kind of thing, and that will give us an equivalent symbolization, so both of those will work. All right. To emphasize the business with the domains, let's look at this one, because this is now a sum one sentence rather than a some dog or some manuscript or some logician. It's a sum one sentence. So here we have a choice about what domain to use. So here we have someone in Syracuse is wise but not happy. So what are the predicates that we're dealing with here? I'm going to use S for being in Syracuse, W for being wise, and H for being happy. And now there's two choices that we can make here for how to symbolize this. We could symbolize it, since it's a someone sentence that's implicitly making a claim about just people, we can symbolize it in a domain of just people if we like. Right, so let's think about that. So this would be saying, okay, there exists some X in the domain of people such that, I should have said about the restrictor predicate, right? The restrictor here is in Syracuse. We're talking not just about people quite generally, but just people in Syracuse. So that's our restrictor predicate. What we're saying is true about some of them is that they're wise but not happy. All right. So in the domain of people, my restrictor predicate goes here, and then, right, that's being from Syracuse, X is from Syracuse, and now I write my main predicate. So how do I say X is wise but not happy? So my main predicate is, well, wise X but not happy X. Right? So what this sentence as a whole is saying is that there exists some object X in our domain of people such that X is from Syracuse and X is wise but not happy. However, if we liked, we could also symbolize this in a domain that is wider than just people, a domain that includes things in general. But still, of course, this English sentence is only talking about people, right? It's saying someone, some person. So now to make that restriction to people explicit, I have to add an additional condition into my restrictor predicate. I have to say there exists some object X in the domain of things such that X is a person and X is from Syracuse. Right? So there exists some object X in the domain of things, which is a person and is from Syracuse, and now I again do my main predicate is wise but not happy. So we have wise X but not happy X. All right, I will get better at this. All right, so those are a couple of symbolizations with